In this video, let's take a look at building a benchtop power supply. The wish list for the power supply is pretty short. I really just want three outputs. I want an adjustable output, I want a fixed 5-volt output, and for a lot of the modern stuff I want a 3.3 volt output. I want something that looks decent, and it doesn't need to be professional, but I don't want it to look like junk, but I want it to look like it was homemade. It needs to be reliable and it needs to be easy to service. I want to use commercial off-the-shelf parts as much as possible, not designing the cards. So if you're looking for the design of the cards, there's tons of good videos up on YouTube. Dave Jones, Jerry Walker, quite a few other people. But to do this, we'll need to learn the limitations of these COTS parts, and we'll probably need to fix and improve things that are limitations in the COTS items that we use. This is what the end result looks like, and we'll take a look at how we got there. But it has an adjustable 0 to 32 volt supply off the shelf. It has a 5 volt 5 amp supply off the shelf part, and an off the shelf 3.3 volt 6 amp power supply. More than enough for the sort of work that I do. There's again quite a few videos up there on higher power, higher voltages, but I've never done much above 32 volts, and these amperages are far above what I normally use, so I'm pretty happy with what the end is going to look like. For the adjustable supply, I'm using the Ryden RD, which is Ryden, I guess, DPS 3005. It's a 0 to 32 volts and 0 to 5 amp supply. There's tons of videos again on this on YouTube. I'm not going to rehash what they've gone through on the videos, but Dave Jones and others have good review videos of this little module. It's small, easy to use, menu system is good. I've found it to be reliable. I bought it with the case when I originally bought it, but I'm jettisoning that because when it's in the case, you still have to provide the 36 or so volts for it at 6 amps, and I end up with another power supply on the bench, and between the two of them, they would take up a fair amount of space. So I think putting this in a box made a lot of sense to me. It's not, like I said, not very expensive at $26, free shipping to the US, and a nice reliable product. I'm not sponsored at all by Ryden. I didn't get anything for free, but I definitely think it's probably worth going to the RD official store on AliExpress if you want to buy one of these. I can't speak for whether there's clones or copies of this thing, counterfeits out there, but definitely it's not very expensive and definitely a nice little product. For the AC/DC power supply, I picked the Meanwell LRS-200 36 power supply. I bought it from Mauser. I'll go over the BOM cost at the end of this. The supply met all the requirements that I wanted. It's a little bit less than 6 amps at 36 volts. I did have a problem when I first turned it on and started to use it, and the problem was that it was not outputting anything, and I found out reading the data sheet that it's not a broad input. It's not one of those 80 to 300 volts, 250, 280, whatever volts. It has a switch on the side. A little bit hard to find at first, but fortunately when I put it together, the switch was accessible without unscrewing the power supply out of the case again. And once I set it to 110, it produced a nice 36 volt output. This power supply is only driving the DPS 3005 part. It's not driving anything else, so it does not drive the 3.3 volts or the 5 volts. Those are all independent outputs, independent grounds. They're not connected together at all. And I did check that with the meter to make sure that they weren't. They're not connected to the chassis or anything like that. Here's the data sheet on the power supply. I'm using the 36 volt output version of the power supply, which provides 5.9 amps. And it's rated from 0 to 5.9 amps. It's a 212 watt power supply. It claims ripple and noise of 200 millivolts peak to peak. Haven't checked it yet. Maybe we'll do that in this video. There is an adjustment on the output, pretty broad adjustment, but I left it alone just like it was. I think it came up at 36 or close to it. The voltage tolerance regulation are all pretty decent, 0.5%. Load regulate or line regulation. Load regulation is also 0.5%. And as I noted, there's a switch on the unit for switching between the US 90 to 132 or nominal 110, 115 volts versus the European and many other places 180 to 264. Make sure you set that switch for your area. I don't know if you could hurt anything if it was set in the wrong position. I did have it in the wrong position, and it runs at European 50 or 60 hertz just fine. The efficiency's okay at 90, almost 90%. It's usually rated at some output power. Not using it, not going to use it anywhere near the 200 plus watts that it's rated for, but it's there in case I do, and the DPS 3005 would support that. The biggest challenge with this power supply is just the footprint. It's 215 by 115 millimeters. Not very tall. It's only 30 millimeters tall, but that's a fairly good size power supply and will drive our enclosure choice. For the 3.3 volt and 5 volt outputs, I'm using one each of the Meanwell power supply, the RS25 series parts, and the 3.3 volt supplies up to 6 amps. The 5 volt supply supplies up to 5 amps. So the 5 is a true 20 watt or 25 watts, but the 3.3 is in truth only a little bit less than 20 watts. Both of these supplies do allow wide input AC range, so you don't have to switch these particular power supplies, and they're really tiny. I've used them in other products before and they've been pretty reliable, so I just decided to use the same thing, and they're real inexpensive too. The footprint of the higher power supply, the 36 volt at 6 amp power supply, drives the enclosure size, and I wanted to use commercial off-the-shelf enclosure, didn't want to make my own. I know it's going to be enough of a challenge to cut the holes in anything I do, and I selected this one off Amazon. It's the YAECC something. There's a couple of different versions of this case on Amazon, but the one that you need is, if you're going to make this, is the bigger case. It's 9.8 inches by 7.5 inches by 4.3, and that's 240 by 180 by 100 inner space, which is just enough. There's not a ton of extra room inside of this thing when you're all done, but it worked. It's big enough with some careful planning of the footprints and judicious locations of connectors and such. For me, the most time-consuming part of any of these sort of projects is cutting the holes and getting them all lined up, and I came up with a couple of tricks in this instance to line things up. I used KiCad PCB design tool and drew an accurate outline of the front panel, and then knew the connector spacings. For instance, BNC to BNC standard spacing between pairs is 3/4 of an inch, and I knew what the cutout for the DPS 3050 was by measuring the part, and drew that up on the front panel. And then I printed this out on an adhesive sticker, kind of a mailing label sticker, and stuck that onto the panel, and it was an accurate 1-to-1 print, and then used that to determine where to cut the holes. For making the big hole, I drill pressed out a few holes near the corners, not too close, and then I use a metal nibbler to nibble out the holes for the rest. If I was a rich man, I'd probably buy something like this tool. Heck, maybe I should just buy something like this tool. It takes me a long time to nibble, but 300 bucks, I don't know. Probably definitely worth having though if you do a fair amount of chassis cuts though. Something like this that just does quick work of all of the nibbling. I usually nibble the whole undersized, and then I will go back with a file and spend quite a bit of time. I'd rather have the hole be a little bit too small and then have to file down quite a bit than have the hole be too big and have a gaping hole in my panel. I've done that too many times. I bought the nibbler I had, I think at Radio Shack, and I don't think I paid much more than this, but the part's still made. It looks quite a bit like the one I have. You might want to add a little bit of padding on the spot that goes between your thumb and your pointer finger, because that will definitely go bad. I nibbled out a whole keyboard when I was in high school and ended up with a good-sized blister there. That's a painful spot to have a blister too. Surprised how much you actually use that opposable thumb that we have. The AC input is one of these C14 that takes a C13, or is it C13 that takes a C14 cable style connectors. Very common. I've got a whole box full of these cables. You probably have at least a box full of them. I like this one because it has, the one is up. When you turn it on, it goes, it's the up position, and I put the switch in the back of the box, so when I reach around and it's up, I know it's on. And the orientation here is the way that I like it too, with the ground pin down, and it just works. I think I bought 10 of them for almost nothing on eBay one day, and I've been throwing them in projects as I go along. The three power supplies are a tight squeeze inside of the box. One of the downsides of this box is the large plastic lip that's in the front and back, and it goes all the way around the inside of the box. And I've done other projects where I've overlapped that a little bit and done things about it, but in this particular case I wanted the metal of the power supply sitting down. The two smaller 25 watt power supplies are mounted somewhat vertically. The power's coming out the sides, and there's not enough room to mount them flat, but they're not going to be too heavily used. I can't see that it'll be a problem for that. I don't foresee putting a fan in here, but that will be part of what we look at with improvements to this. And I've got really just the basics of hooking it up using 18 gauge silicone wire, which I bought. I like that kind of wire. It's fairly easy to deal with. And then just the normal ring type terminals for hooking up everything. And it's fairly straightforward. Here's another view. The AC power cord, and it has to be near the top, and I kind of want it near the top anyhow because I want to reach around and hit the switch, either reach over the top or reach around the side and hit the switch. So I kind of want it near the top back corner. The two power supplies, you can see the smaller power supplies are mounted somewhat vertically there. And the cabling is, it's okay. Zip tied it, or zip tied it all. Cable ties. And not a lot of fancy stuff going on here. You can see the banana jacks fit across the front with the 3/4 of an inch spacing between all of them. Potentially like to add a ground here, but this case is essentially metal plates that are not bonded together in any way. So I think it would not exactly do what you might think, but it would be nice to have a jack out in the front, at least for connecting to earth ground. I live in an old house, and a lot of the jacks are not earth grounded. You can measure a potential between the ground pin, the earth ground, and both of the powers. So something that probably needs to be fixed in my old house, but anyway, that's a whole different subject. The switch gets wired directly to the IEC. I'm switching the hot using the standard electrical housing colors of white and black for those cables, which could be confused with the black and red of the DC cables, but hey, I think I can keep a couple of wires straight here. Decent view though of what it looks like from the outside, and you can see sort of the space that's left in the back if there was to be more things back there. The binding post or banana jacks in the front are on the center line of the front panel, which I think is probably fine. They can't be much lower because of where the height of the meanwhile power supply. The DPS 3050 has to be higher, unfortunately, because it would run into the DPS 3050 power supply, and I wanted to leave a fair amount of space there. So that was part of the advantage of printing out an adhesive sheet. The first one I printed out, I just threw it down in the center, and then I flipped the panel around and stuck it on the inside with the markings, and it said, oh man, that's just going to be way too close to the top of the big meanwhile supply. So that was a good case for doing that, and then said I just better move it out and kind of center it up a little bit higher, and it worked well. Here's the view looking from the back towards the banana jacks in the front and the DPS 3050. There's enough room to clear the plastic shell of the case. Again, the case is largely plastic on the edges and then metal plates that are not connected together except because everything basically screws in the plastic. It does have these nice reinforcing bars front to back, and they're removable, so if you need to drill something out and they're in your way, they're easy enough to remove. They've got nuts behind them even. It's not like they're even just drilled into plastic. They've done a nice job with construction of this case. It's pretty straightforward hookup and such here. There's a trade-off here between routing the cables away from the power supply and having shorter cables, and I opted in favor of having shorter DC cables, with the cost of being that they're a little bit sloppy running over the power supply instead of being cleanly routed through the edges of the case somewhere. But the AC is mostly tucked around the side, so it's not too close to the AC power cables themselves, so it shouldn't pick up much noise from there. The DPS power supply has a nice little connector that it comes with, and they give you the mating connector, and it's a little screw terminal push-in type of connector. Wiring is a little bit funky. The two centers are the grounds, and the ins and outs are on the pluses are on the outside. So be careful, look at your silk screen if you play with one of these. If you hook it up wrong, I think things might go bad. But it's pretty plain and straightforward here. Here the unit's turned on and the DPS 3050 is up and running, and I did test power on all the jacks and everything before I screwed the cover onto it. To mark what things are where, I use P-touch labels, and the white on black isn't a bad scheme with this particular panel. I think it's, or the color, the white trim on the cabinet sort of matches that. Could have used white on black instead of black on white, but I think this works just fine. It fits the design goal of not professional, and definitely looks homemade, but it doesn't look horrible. I'm pretty happy with what this looks like. If you're doing a professional project, of course you would send this out or silkscreen it if you have silkscreen capabilities where you are. Otherwise, this is more than adequate for use, and it definitely is big letters. I like the high contrast. You get older and it's harder to see stuff. So many electronic products we buy today, you kind of have to get a flashlight to look at them. My microwave, I can't tell which button's the clock button. I don't know why they don't just make stuff much higher contrast for making it easier to see and read, especially when it's a little bit darker. Hopefully this will work just fine. The rear markings indicate that it's set for 110 volts US power, and just for fun I put the 250 watts maximum, which is the sum of all three power supplies use, just so I know. It'll never get anywhere near that, hopefully, or it might. One thing I'm missing here is a fuse. There's plenty of room to add a fuse, and I've ordered one, so I'll probably be adding that as, or will be adding that as one of the improvements here. Not particularly worried about that. We plug stuff like this in our house all the time, and very few things are fused nowadays, but test equipment, it's probably a good idea because it's possibly being used in a way that it shouldn't be used at times. The supplies are probably all protected for that, but regardless, I think I'm going to add, or I will add, the fuse to it. So this is a pretty decent bare bones power supply. The 5 volts at 5 amps and 3.3 volts at 6 amps. Definitely powers a lot of logic circuitry. Definitely more than what I'm doing on any of the projects that I have all put together probably. And the adjustable supply is very nice and convenient. I've used that quite a bit already in other things that I've worked on in the smaller enclosure, but it was just inconvenient. Don't know yet if it's going to need a fan. Don't have one in here. Of course, it depends upon the loads and how much is being drawn and all that sort of thing. Probably won't put one in here unless I'm doing something that really does need it. The side panels are louvered. They have slots cut, so a fan could easily be mounted in the side and certainly powered off either the 5 volts or probably the 5 volts could power it just fine. I have not connected, as I mentioned earlier, the grounds together in any of these three, so I could be doing three completely independent projects. If I wanted them connected together, I would just wire them together, binding posts and cables, or use the right kind of banana jacks with the female on it. The cost of doing something like this is surprisingly expensive, but if you look at each of the pieces, they're quite reasonable. Like the case for 20 bucks, you can't make anything for 20 bucks that has good quality like that. The high power 200 watt power supply for 32 bucks, that's really pretty reasonable. Those RS-25 supplies from Mauser are only $12 a piece. I mean, not much more than twice the cost of a piece of junk wall wart. They're nice, much nicer supplies. Banana jacks and hookup wire that AC switch, probably $1 if you're buying a bunch of them. That DPS 33005, if you buy the USB attachment for them, then it's another 29. It's $29. Without it, it's 26. I didn't put the panel meters on here. I was considering doing that. I really didn't see the point. The adjustable supply has a nice enough voltage indication, and the other two are fixed, so it's not like they're going to vary much. Something to think about, but hey, if I did anything, I'd rather throw extra jacks on and have multiple places to hook up to the 5 volts rather than play around with panel meters at this point. This is definitely gives me what I want for a lab supply. Take a look and possibly do other videos because I've got some improvements coming along for it, and we'll take a look at what sort of things we can do to characterize this and then improve the performance of it. But I think I'll leave it at now. This video is getting long enough. Thanks for watching. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.